Hello everyone. Welcome to the first ever SNIA Storage Security Summit. My name is Don Matthews and I'm the President and CEO of NexiTech Incorporated. I want to thank the summit organizers for the opportunity to be with you today, and I also want to thank you for tuning in. I am very excited to be here because this summit represents a confluence of subject matter experts from the cybersecurity and data storage arenas getting together to form a brand new community that, in my opinion, is extremely relevant. My goal for this presentation is to educate the storage security community on a couple of emerging topics known as active cyber defense and moving target defense. Now, I'm not going to pretend that this is some kind of silver bullet that is going to provide sweeping protection for every kind of cyber attack under the sun. But for those of you looking for a way to differentiate your storage security solutions, this can be another tool in your toolkit. It takes an ecosystem of solutions from different vendors, and moving target defense can be a part of that ecosystem. Again, thank you very much for stopping by and for the opportunity to be with you. I really appreciate it. Today I'll be briefing you on a moving target defense solution that provides enhanced protection for critical data storage devices. I'm going to tell you what we do, how we do it, and why it might matter to you. I'll start off by taking a look at where this new technique fits in with respect to all the different layers in a modern computing system, and I'll also describe some of the foundational work that we've done with respect to military aircraft mission planning environments that later evolved into our current moving target defense solution. I'll then talk about how we do it. I'll describe the technical attributes of the solution and the reference architecture that we developed while working with the Department of Homeland Security. And then finally, perhaps the most important section, why do you care? Why does this matter to you? Ransomware continues to be a big problem for everyone, and this solution provides effective protection from ransomware. But cyber attacks can actually cause real-world physical damage, and I'll be offering a few examples of how that can happen in the data storage world. Modern computing systems are, for the most part, static in nature, and that makes them easy to attack and hard to defend. Attackers have all the time in the world to plan an attack at the time and place of their choosing, and that gives them an asymmetric advantage. Dynamic defense, specifically moving target defense, seeks to introduce controlled change and uncertainty to multiple network and system dimensions. This serves to decrease the attacker's window of opportunity and increase the economic costs of the attacker's probing and attack efforts. That takes away their asymmetric advantage and also renders the attacker's surveillance obsolete. Now let's dive in and take a closer look at a few common storage devices and define exactly what we mean when we talk about the attack surface. I'm also going to talk about how we change multiple dimensions of the attack surface simultaneously. When we take a look at all the hardware and software layers that are present in a modern computing system, we find that there are many vulnerabilities and there are many different vendors providing solutions for almost all of these layers. We have chosen to focus specifically on the data storage layer. This is an area that has typically not received quite as much attention from the traditional cybersecurity vendors, but this is the layer right next to where the data lives, if you will. See, if an attacker manages to somehow get through all of the defense mechanisms that have been put in place through some undetectable means or by using some techniques that are not known at this time, and they make it all the way down to the data storage layer, then we believe there are some seriously bad things that can happen. Not only with respect to altering the data or observing the data, but also with respect to the enclosures that contain these devices. These are the devices that provide power and cooling for the data storage devices. You know, we're always talking about the cloud, but that's basically just a bunch of servers and storage in a data center somewhere, right? And if you were to go into this data center, you would find racks of enclosures containing various types of data storage devices, including regular spinning magnetic media, to all-flash devices, and perhaps even other devices like tapes and tape libraries as well. So let's take a look at the attack surface for some of these devices that I just mentioned. And as we do, I'd also like to draw a distinction between the data surface and the control surface. The commands that most of us think of when we think of a disk drive are the standard read and write commands. That's what we mean when we talk about the data surface. These are the commands that are used 99% of the time when talking to a disk device, but there's also a control surface. The firmware for a disk device maintains metadata that describes how the device reacts with respect to its environment. Depending on what the temperature is doing, for example, there are commands that can be used to influence the device's behavior. I mentioned enclosure devices a moment ago, and again, these are the devices that control the power to the disk drives and the fans that keep them cool. Temperature sensors are also embedded in these enclosure devices. We've got tape devices, which may be used mostly for archival purposes, but there's also tape libraries or medium changers. These are the robotic devices that are responsible for moving a certain tape or media from a slot to a particular drive. This slide serves to summarize the data and control attack surfaces for several types of storage devices, along with examples of the risks associated with each of these attack surfaces. Let's take another look at an alternate depiction of the storage-related attack surfaces. Here I've shown the data interface at the bottom, and I'm listing some of the risks that could be associated with an attacker's ability to snoop commands. For example, if an attacker can snoop the data coming back in response to a read command, then that results in a data breach or data compromise. If the attacker can inject a write command into the stream, then that could alter the media. Changing just one block on the media could potentially have devastating effects that can render the whole device unusable, for example, in the case where it's the boot drive on a computer. But the control surface is the one that we think has really been unappreciated, and these are the commands that are used to control things like formatting the media, where a single format command could wipe out all the data on a storage device. More subtle and sophisticated attacks would include the ability to monitor the results of commands that are reporting temperature. Let's say that an attacker could intercept this data and make the temperature look a little bit lower than it really is. The host thinks that everything is fine, so it slows down the fans. Meanwhile, the temperature is rising inside the enclosure. It's getting hotter, and now bad things can happen. Obviously, the worst case is where the device fails completely, but an even more subtle case would be where the device doesn't fail, but the temperature has risen just enough for thermal throttling to kick in. Now, this is a feature on modern solid-state drives that monitors the temperature inside a device. When the temperature rises, the processor slows down, and now this could result in a quality of service attack. In some systems where the performance is very critical, for example in a weapons system or perhaps a stock trading system, this could be a very devious, subtle, and even deadly attack. And of course, the most extreme case here is where the device just literally melts down. The temperature rises to the point where the devices fail or they're irreparably damaged, and now you've got a serious denial of service attack. But an even simpler attack might be if the attacker just tries to power off the drives. There are a number of bad things that can conceivably happen with these rarely used control surface commands. We're seeking to introduce active cyber defense to the data storage industry for the first time ever. We see our place as bridging the gap between the data storage domain and the cybersecurity domain. And that's precisely why this summit is the perfect place to talk about this emerging technology that sits at the intersection of storage and security. Now I'd like to talk a little bit about the foundational work that I mentioned earlier. Our first commercial product was a software interface layer that basically translated one storage-related API into another. In the early days of Windows, Microsoft included a particular type of storage API called ASPI, and many vendors implemented application programs that used this interface, including the US Air Force. In later versions of Windows, Microsoft dropped that API in favor of a different one that they came up with, and so it was necessary to translate between the old one and the new one in order to provide backwards compatibility for those folks that had created applications that used the old API. The Air Force was one of those customers, and in that particular case, the objective was to migrate applications from Windows XP to Windows 10, but the API translation itself was not the most interesting part. The most interesting part ended up being a cybersecurity problem in which Microsoft had tightened up their security restrictions on its newer API, and in fact, that's a pattern that Microsoft has repeated with successive versions of Windows. So we essentially had to find a way around that in order to satisfy the Air Force's requirements. The new requirement from Microsoft was that these APIs could only run with administrative privileges, and the Air Force said, no, our software needs to run with user privileges without elevated permissions. And so we solved that problem, and our software was deployed in the C-130 mission planning environment. Next, the Navy needed to solve the same problem with respect to the presidential helicopter. Here we needed to solve another security problem that I won't go into right now, but once that was done, our solution was deployed for use with Marine One. Now that was very thrilling and gratifying. It was really cool to help the DoD in that way, but after that experience, we sat back and thought, basically what we did here was we found a way around these security restrictions from Microsoft. And that means that we can now send any storage-related command we like to any storage device. That's a pretty powerful capability. If we can figure out how to do that, someone else probably can too. So that was the motivation and the inspiration for coming up with our moving target defense solution. And then a few years later, we received an award from the Department of Homeland Security in conjunction with the Silicon Valley Innovation Program for the purpose of helping to secure critical national infrastructure, specifically the financial services sector. Let's talk about how it works. At its core, we use storage virtualization to create multiple abstractions of a device. We also change the device type. We have the capability to emulate any type of device we want, so we could, for instance, take a disk device and make it look like a tape device, or make it look like an unknown device. So we've cloaked the device by changing its device type. The host operating system now has no idea how to talk to this thing because it's no longer a disk drive. This alone is an effective ransomware protection, by the way, because most ransomware attacks depend on the fact that there is a usable file system on the disk device. No file system, no ransomware attack. This is why tape drive vendors can rightfully claim to be resistant to ransomware attacks. Anyway, by making multiple abstractions of the device, we've essentially created multiple paths to the device, and you can call these whatever you want. Multiple virtual communication channels or virtual ports. Either of those terms work for me. But in addition, we also obfuscate the command set. These commands that are used to control the power and then read and write to the device, they're all described in open standards. So anyone in the world can understand how the command is formatted and what all the bits mean. That's exactly what helps promote interoperability in the storage world. Well, that information is all known to attackers, right? So we're going to obfuscate the command set. Next, we introduce a moving target defense by randomly hopping around on these virtual channels. The two entities, the host and the target, are kept in sync with one another with respect to what channel is being used, and we also randomly change the command set. So we're changing multiple dimensions of the attack surface, and we're doing this in an autonomous manner, and that creates a moving target defense which is unpredictable to adversaries. The result is an autonomous system that randomly changes multiple dimensions of the attack surface, making it unpredictable to adversaries. Let's take a look at the reference architecture that I mentioned. The API translator that we developed is used on both sides of this software stack. I'm showing a small subset of the layers that are involved in talking between a host and a storage device. In this case, I put an appliance in front of the device itself, so the moving target defense framework really is just a small layer, a shim layer, you might call it, that sits either above or below our API translation layer, depending on which side of the diagram you're on. Ethernet and fiber channel are two physical transports that we've used in our demonstrations of this technology, but in the storage world, there are obviously plenty of other legacy transports, such as SATA, SCSI, and SAS. And of course, the latest and greatest storage interface is no doubt NVMe, and we are also subject matter experts with that protocol as well. We will soon be extending our reach to NVMe over fabrics. Summing up the technical attributes of our solution, it's autonomous, multidimensional, changes both the channel and the command set at the same time, and uses randomization to make it unpredictable by adversaries. This results in a dynamic network configuration. We can gather metrics and report breaches, and we could also optionally create a honeypot. I mentioned earlier that we have the ability to emulate any type of device, and therefore we could put a device out there as a decoy, and if an attacker tries to talk to it, flag that as a potential breach. This solution can be described as address space layout randomization for data storage. Why on earth would you want to work with us? Well, we continue to evolve this technology, and we're exploring market opportunities with our existing base of clients, which includes some of the most highly respected big dogs in the industry. These are names that I think you all would probably recognize, such as Dell, Intel, Microsoft, Quantum, Micron, and others. We're attempting to form a network of partnerships with the big dogs, companies like these and others. And we're exploring new use cases. And this is where you come in, by the way. If you've got any ideas regarding how you would like to further investigate this technology or use it in some sort of a pilot program, we'd love to talk to you and pursue that further. And with our deep subject matter expertise in NVMe and kernel mode device drivers, we can help you solve a broad range of state-of-the-art storage security problems. In summary, the core technology is adaptable. It uniquely protects data in flight for the storage data surface and also the storage control surface. It can exist in an appliance, or it can be embedded in the device itself. And finally, this is one more tool in the toolkit when it comes to fighting ransomware and stopping cyber attacks. So why is this important? I mean, why does it matter to you? Well, the real reason that this is relevant today is because cyber attacks continue to happen on a daily basis. As we all know, there just seems to be no end in sight for all of the attacks that continue to come, whether they're high-profile data breaches or whatever. Ransomware attacks are on the rise, and they have been for years. I think it's important to understand that preventing cyber attacks is not easy, and that there is no single silver bullet that is going to provide protection for every kind of attack. It's going to take a community like this, which the SNIA has wisely assembled with subject matter experts from the cybersecurity realm and also the data storage world. It's going to take an ecosystem of solutions from different vendors, and we view moving target defense as part of that ecosystem. In other words, it's another tool in the toolkit that can provide additional value in the right situation. You know, it's not unlike the situation you might have in your house where you lock the front door, you lock the windows, you even install an expensive security system, but things still can happen. And at the end of the day, if an intruder manages to get in and make it all the way down the hallway to the bedroom door where the baby is sleeping, We would like there to be a little surprise on the other side of the door. And we would like moving target defense to be that big dog that is right there protecting your precious data at the lowest layer. We're trying to introduce active cyber defense to the data storage industry for the first time ever. That's all I have, folks. Please review our virtual expo page and download our slide deck for additional bonus slides that I was unable to cover in this talk. And please don't hesitate to reach out if you want to learn more about moving target defense. Thank you very much for your time. I'd be more than happy to answer any questions.